Today we're going to just start off and review the different things we've done the last 2 days. And then in a second, we're going to practice like deciding if it's arithmetic or if it's geometric. All right, so on this chart, this very last column is not something that we do anymore in Algebra 2 in the state of Tennessee. So we're just going to mark out that very last column. We don't need it. But the rest of the stuff will be kind of nice to have all your formulas in one place and a couple of examples of each of them. All right, so let's start with the arithmetic sequence. So the definition of an arithmetic sequence is a list of numbers with a common difference. I'll squeeze that word in there. So this is going to be examples where you are adding something each time to get the next number. Now, to find the common difference, we would always, you can take any number and subtract the previous one from it, but normally we would just do the second minus the first term. All right. So I did tell you that there's a formula, but it's not going to be on the formula sheet when you take the EOC. It's also going to be on your test when you take the test on Friday. So it's not something you have to memorize, but we'll go ahead and write it. It's A sub n is equal to A sub 1 plus, in parentheses, n minus 1 times D. And so that will give you, like, if you plug in all the things, that'll give you, like, the formula to find a certain term. And then if you plug in, like, 2 or 3 for n, it'll give you the second term or the third term. So on this example, it tells us to find A sub 28. So that's telling us to find the 28th term. And we're going to use the formula to do that. All right, so to use that formula, we need the first term, which obviously is negative 5. And we need the common difference. So what is being added each time to get the next term? Or if you can't do that in your head, it's okay. You can take the second term and subtract the first term from it. 14, good. All right, and if they're asking us to find the 28th term, that's going to mean that n is 28. All right, so now I'm just going to go back and I'm going to put all of those numbers into my formula. All right, and then you can just type that in a calculator just like it looks. Or you could just do negative 5 plus 27 times 14. Either way, we are going to get that the 28th term is 373. Okay. So just a review. Like, this is nothing new. This is stuff we did on Fridays. Been a little while. All right, let's do one more like that, and we're going to move on to something different. So on this one, it's telling, this is the arithmetic sequence row or column. So this one is telling you it's arithmetic. The first term is 9. Now to find the common difference, this one might be kind of hard for you to do in your head. I don't know how good you are at subtracting in your head, but you can just type that in, the second minus the first. Now 13 halves, you can just type as 13 divided by 2 if you wanted to, or you can do the alpha y equals. So we can say that D is negative 2.5, or as a fraction, would that'd be negative 5/2. Either one. I'm just going to go ahead and use the decimal. All right, and we're finding a sub 23, so that means that n is 23. Okay, so what I'm going to do is just take those things that we just found and plug them right into the formula. Right, then you can just type that in just like it looks. And you should get that the 23rd term is negative 46. Okay. So let's review of arithmetic sequences. All right. So our next column is geometric sequences, which is what we talked about yesterday. So a sequence is always going to be a list of numbers. So we have a list of numbers. With a common ratio. So this is a situation where you're multiplying by the same thing every time. And if you need to find that common ratio, you're going to divide a number by the previous number. So we can divide the second term by the first term, and that's going to give us what we're multiplying by each time, the common ratio. Arithmetic, yeah, arithmetic is adding, geometric is multiplying. So the formula is, again, you'll always have it available to you. It's not something that you need to memorize. So it's a sub n is equal to a sub 1. And then in parentheses we have r, which is the common ratio, raised to the n minus 1. Okay, so we're going to do a couple of these examples. So this is a geometric sequence. The first term is negative 8. All right. Can you just look at it and tell what you're multiplying by each time? Negative 2. So if you can't tell, it's okay. You just take the second term and divide it by the first. That's going to be negative 2. All right, and then this one is asking us to find the 14th term. So n is 14. All right, so I'm just going to go back and I'm going to plug in all the things into my formula up there. And then you would just type that in the calculator, and it's just a pretty big number, 65,536. All right, you guys okay? Okay, one more of these and we'll move on to some series. All right, so the first term is 1,024. Now, I couldn't do this r in my head. I actually had to divide it. So I took the second term and I divided it by the first term, and I got 0.75. Do you guys know what that is as a fraction? 0.7? It's 3/4. So you could either use 3/4 or 0.75. I'm going to just use the decimal. All right, and then n is going to be 7. Okay, so we're looking for the 7th term in this sequence. So I just typed all that in the calculator and I got 182.25. Okay, so that was from yesterday. So hopefully it feels a little familiar. All right, and then Friday, we also did the arithmetic series. So what's the difference between a sequence and a series? This is what the sequences looks like, these two. And this is what the series looks like. What's the difference? You're adding. Good. So a series is going to be the sum. So an arithmetic series is the sum of an arithmetic sequence. Now there is a formula to find this sum, but it's not on our reference sheet. It's kind of an annoying formula to use. So if you guys remember, what we did is we just wrote a summation. All right, so it's going to be the summation from n equals 1 to whatever this number is, goes on the top. And then we just use this formula right here. All right, so it's going to be a sub 1 plus n minus 1 times d. Okay, so we're only going to do this one example. I'm going to talk about that second example, but it's just type it in the calculator. I'm fairly confident that you all can do that. So on this example, we're going to find S sub 37, which means we're going to add up all the terms from 1 to 37. Oh, I didn't write all the things down. Okay. So a sub 1 is -3. What are we adding each time? It should be -4. We're basically subtracting 4, so that's adding -4. All right, so it's going to be -3 plus n minus 1 times -4. Do you guys remember how to get that summation? Do you remember how to get log base?
Alpha window 3.
Okay, so go to alpha window. If we ever wanted to do log base again, it would be 5, but the summation is 2. Okay, and then you just fill in the things. And it just gives you the answer. It's great. I love that button. All right, now if you had forgotten how to do it, you can make yourself a little note on here if you want to. It's alpha, window, and then a 2. You're going to want to remember that. All right, so on this example too, I'm not going to do it, but I do want you to know that whenever you're doing a summation and the function part looks like this, that's what arithmetic looks like. You'll have like an n or an x or something. It won't have a power or anything. Just be basically a linear function. Okay, so let's go to the last thing we're going to do is the geometric series. And so it's going to be the sum of a geometric sequence. Oops. And it has a formula to use. We technically could kind of do this same thing if you wanted to, but with this, that will work. But since you're given the formula on the formula sheet, I wanted to practice using it. So it's going to be S sub n equals a big long fraction. So if you weren't here yesterday, this is one of the things we did. And on the top is a sub 1 times 1 minus r to the n. And then on the bottom, it's 1 minus r. And it's not something you have to memorize. I will always give that to you when you need it. All right, so this next example is a geometric sequence. A sub 1 is 2. Can you tell what we're multiplying by each time? -3, good. And then n is going to be 12 because it tells you the 12 there. So we're adding up the first 12 terms. So I'm going to move down. It's going to take all those things we just wrote and I'm going to put them in the formula. Now, if r is ever a fraction or a negative, I recommend that you type it in or that you put it in parentheses. Otherwise, you might not square it right or might not raise it to the power right, or something might get weird with the subtraction. Right. On this, I would recommend that you do alpha y equals and get this little fraction guy. That is going to be the sum of the first 12 terms. All right, now we're not going to do this very last one.
720.
It is. I just wrote my 2 upside down. Sometimes I do that. Thanks. So this last one we're not going to do, but I do want you to look at it because sometimes it's written this way and you have to decide if it's arithmetic or geometric. But so if it looks like the rule for geometric sequence, then that's going to be geometric. Okay, so I'm giving you another sheet. This is the day of many papers. This is going to be a 2-page note sheet, and then your assignment will be a 2-page homework sheet. And we're only doing the first 6 summits today. It shouldn't take too long. All right, so on the first 3, we're going to decide if they're arithmetic, geometric, or neither. And then if it's either arithmetic or geometric, we're going to go ahead and write the rule. So I'll remind you what all that means. Okay, so when we're deciding arithmetic or geometric or neither, you're asking yourself, are you adding something each time? Or are you multiplying by something each time? Or neither? So what do you guys think about number 1? It's geometric. You could technically say you're dividing by something each time. What are you dividing by? 3. So that means that you're multiplying by 1/3. So if you have a hard time figuring that out, you can take the second and divide it by the first, and you get 1/3. And then if you took the third and divided by the second, it's going to be 1/3, and so on and so on. All right. Our first term, obviously, is 15. All right. So it might be a good idea to keep that half that sideways sheet out. And so we're talking about a geometric sequence. So it's this second row, second column. That's the formula we're going to use. And so n is going to be n. We're writing the rule. So a sub n is equal to the first term. And then in parentheses, we'll put our common ratio raised to the n minus 1. And that's it. We don't have to find any term. We just have to find the rule. All right. So let's look at number 2. Are we adding something each time or multiplying by something each time or neither? Oh, sorry. Yes. So it's just asking us to write the rule, and that's the rule. What do you guys think about 2? Arithmetic, geometric, or neither? What are you adding? Well, if we add 1 to 1, we get 2. We don't get negative 2.
You're subtracting like 1. Wait.
This one's neither. It's probably it was the first one we've done that's neither. So no, this is a pattern, but it's not we're not adding or multiplying on this one. Neither is great because then we're done. We just go on to the next question. All right, what do you guys think about 3? Are we adding or are we multiplying? We're adding 7. So this is arithmetic. So negative 18 plus 7 is negative 11. Negative 11 plus 7 is negative 4. Negative 4 plus 7 is 3. So yeah. All right, the first term is negative 18. All right, so on this sheet, we're going to look at this first row or first column. We use that formula. A sub n is equal to negative 18 plus n minus 1 times 7, and that's it. All right. All right, let's go to number 4. So these, we're going to decide if it's arithmetic or geometric. These are not going to be neither. So arithmetic and geometric, and then we're going to find the sum. So what do you guys think about 4? Are we adding the same thing or are we multiplying? We're adding. So it's arithmetic. What is it we're adding? If you're not sure, take the second number and subtract the first. So that's going to be negative 4. Isaac, are you okay? You can't even hear me. All right, so we're going to find the sum of the first 26 terms. So if it's arithmetic, this is the rule in this third column. We're going to go from 1 to 26. All right, so, and then we're just going to use that arithmetic rule. So it's a sub 1 plus n minus 1 times d. And then you just type that in, and your calculator just magically adds all those terms and gives you negative 1,222.
Where would you like? In what line of work would you?
I'm glad you asked that, because tomorrow we're going to spend a big portion of the day doing applications of sequences and series. All right, let's look at number 5. Sure. Good. Okay. What do you guys think is 5 arithmetic or geometric? You can tell it's not going down by the same amount. It's like that goes down by 30 and then that goes down by 15. So we're dividing by 2. It's geometric, but dividing by 2 is the same as multiplying by 1/2. So R is going to be 1/2. Okay, so we're going to use the rule that's under geometric series. So S of 14 is going to equal the first term times 1 minus R raised to the 14 over 1 minus R. All right, and then that's just going to give you 120. And then number 6 is already set up for you. We just need to decide if that's going to be arithmetic or geometric. So what I want you guys to do is look at these last 2 boxes right here. Which one of those does that look more like the geometric? So it's going to be geometric. And you can just type that in. I'm just going to go ahead and tell you so we can save on time so you have some time to work. It's negative 1,530. Okay, I'm going to give you your worksheet. We are not doing all of these, not even close. So I'll tell you which ones to do.